Last week we learned loops, how to repeat code efficiently. This week we learn to organize it. Functions are reusable blocks of code. Write once, use anywhere. Instead of copying the same lines over and over, you wrap them in a function and call it whenever you need it. This is how professional code is written. Clean, organized, maintainable. Let's build some functions. A function is a named block of code that only runs when you call it. Here's the basic structure. We write def, then the function name, then parentheses, then a colon. The indented code below is the function body, the code that runs when you call it. Let me show you a simple example. We define a function called greet that prints hello. The function exists, but nothing happens yet. It only runs when we call it by writing the function name with parentheses. Now, hello appears. The function executed. Here's the power of functions. You can call them as many times as you want. 3 calls, 3 outputs. Write the code once, use it forever. Functions become really useful when you can pass data into them. That's what parameters are for. We add a variable name inside the parentheses. This is the parameter. When we call the function, we pass a value. That's called an argument. Inside the function, the parameter holds that value. Here, we're greeting Alice. The name parameter contains Alice, so we print, "Hello, Alice." The same function works with any name. 3 calls, 3 different names, 3 personalized greetings. One function handles them all. Sometimes you don't want a function to print something. You want it to calculate something and give you the answer. That's what return does. This function adds 2 numbers and returns the result. We capture that result in a variable called result, then print it. The function didn't print anything itself, it just calculated and returned. You can also use the return value directly without storing it first. Here's the key difference between print and return. Print displays something on screen. Return sends a value back to wherever the function was called. You can use that returned value in calculations, store it, pass it to another function, anything. Return is how functions communicate results back to your code. What if a parameter is optional? You can give it a default value. The parameter has a default of world. If you call the function with an argument, it uses that. If you call it without, it falls back to the default. Alice overrides the default. The empty call uses world. This is useful for functions where most calls use the same value, but you want flexibility. The power function squares by default. Exponent is 2, but you can override it to cube or use any power you want. Functions can take as many parameters as you need. Just separate them with commas. This function takes name, age, and city. When you call it, you pass 3 arguments in the same order. Order matters here. Python matches arguments to parameters by position. First argument goes to first parameter, second to second, and so on. But you can also use keyword arguments, explicitly naming which parameter gets which value. Now order doesn't matter. This makes your code clearer, especially with many parameters. Variables created inside a function only exist inside that function. This is called local scope. We create X inside the function. It works fine in there, but try to access it outside. Error. The variable doesn't exist in the outer scope. Variables created outside functions are global. They can be accessed from anywhere, including inside functions. Here, name is global. The function can read it without any issues. Be careful with scope. It's a common source of bugs when you're starting out. If a variable isn't working, check where it was defined. Let's see some real-world functions. First, a temperature converter. Pass in Celsius, get back Fahrenheit. Clean, reusable, does one thing well. Second, a validation function. Check if an age is valid between 0 and 120. Returns true or false. You can use this anywhere you need to validate age input. Third, a simple calculator. Takes two numbers and an operation. Defaults to addition but can subtract or multiply. This pattern, a function that behaves differently based on a parameter, is incredibly common. These are the building blocks of real programs, small functions that do one thing well, combined to build complex behavior. That's functions in Python. You now know how to define functions with def and call them by name. You know parameters for passing data in and return for getting data out. You know default parameters make arguments optional and keyword arguments make calls clearer. You understand scope. Local variables stay local. Global variables are accessible everywhere. Functions are how you organize code. Small, focused, reusable. Every serious Python program is built from functions. Next week we're covering lists, how to store and work with collections of data, multiple values in a single variable. If this helped, subscribe. New tutorial every week, and we're building towards real projects. See you in the next one.